Mars, our closest planetary neighbor. A cold, dusty desert world today. But what if Mars was once like Earth? What if ancient Mars had vast oceans, flowing rivers, and a thick atmosphere? Could life have once thrived on the red planet? For decades, scientists have been searching for answers. Did Mars have liquid water? What happened to its atmosphere? Could life have existed there? Recent discoveries from NASA's Curiosity and Perseverance rovers, along with satellites orbiting Mars, have revealed astonishing evidence of a once habitable world. Riverbeds, deltas, and even signs of ancient tsunami suggest that Mars may have looked very different in the distant past. But how did it change? And could it one day be terraformed back into a living world? Join us as we travel back in time, billions of years into Mars' past, to uncover the secrets of its lost world. This is the story of ancient Mars, the geography of the red planet. For centuries, Mars has fascinated astronomers, scientists, and dreamers alike. Even before we sent spacecraft to study it, we wondered, could Mars have once been like Earth? Keycap 1 Early Observations, the Martian Canals, and the First Theories. In the late 19th century, astronomers using primitive telescopes noticed dark streaks across Mars' surface. In 1877, Italian astronomer Giovanni Schiaparelli mapped these dark lines and called them canali, Italian for channels. American astronomer Percival Lowell misinterpreted this as evidence of artificial canals built by an intelligent Martian civilization. The idea of a dying Mars with an advanced race struggling to survive fueled science fiction, but it was later proven to be an optical illusion. Even though the canals were a myth, they sparked a deeper interest in the possibility of water and life on Mars. Keycap 2 The First Space Probes, a disappointing discovery. In the 1960s and 1970s, space agencies launched the first robotic explorers to Mars. Mariner 4, 1965, took the first close-up photos of Mars. Instead of lush landscapes, it revealed a barren, cratered wasteland, more like the moon than Earth. Viking 1 and 2, 1976, searched for microbial life in Martian soil, but found no definitive signs. Scientists began to question, was Mars always this way, or had it changed over time? The key to understanding Mars was not just on the surface. It was hidden in its ancient landscapes. Keycap 3 The Geological Clues to a Watery Past. As technology improved, new missions uncovered stunning geological evidence that ancient Mars once had liquid water. Mars Global Surveyor, 1996 to 2006, mapped the surface and revealed ancient river valleys and lake basins. Mars Odyssey, 2001 present, found vast underground reservoirs of ice, proving that Mars still holds water beneath its surface. Opportunity Rover, 2004 to 2018, discovered hematite blueberries, tiny mineral spheres that form in liquid water on Earth. These findings suggested that ancient Mars was once a very different world. A world with water, a thicker atmosphere, and possibly even the right conditions for life. Keycap 4, when was Mars most Earth-like? Based on rock samples and climate models, scientists believe that about 3.5 to 4 billion years ago, Mars had oceans covering nearly 1/3 of its surface, a thick atmosphere allowing rivers to flow, a magnetic field that protected it from solar radiation. However, something catastrophic happened that turned it into the cold, dry world we see today. But what caused this dramatic change? How did Mars lose its atmosphere and water? The answer lies in its geography and in the forces that shaped its surface. Summary of the historical background section. Heavy checkmark: early astronomers thought Mars had artificial canals. This was a mistake. Heavy checkmark: the first space probes showed a barren world, but later missions found evidence of ancient water. Heavy checkmark: Mars once had rivers, lakes, and even oceans, but something caused it to dry out. Heavy checkmark: understanding Mars' ancient geography can help us solve the mystery of its past climate. To understand what ancient Mars was like, we must explore its surface, its mountains, valleys, and riverbeds, each telling a different story of the planet's past. Mars today may be a barren wasteland, but its geography reveals clues about a time when it was a world of water, wind, and fire. Keycap 1: The Lost Oceans of Mars. Was there a Martian sea? One of the biggest mysteries of Mars' past is whether it had a large ocean. Scientists believe that billions of years ago, Mars had an ocean covering nearly 1/3 of its surface, mainly in the lowland plains of the northern hemisphere. The Mars Orbiter Laser Altimeter, MOLA, found evidence that the Martian surface is divided into two regions, the southern highlands and the northern lowlands, suggesting that the northern basin could have once held water. Shoreline-like formations detected by Mars Reconnaissance Orbiter hint that these regions could have once been coastlines. Small blue diamond, the case for an ancient Martian ocean. Microscope scientists have identified sedimentary deposits, ancient deltas, and erosion patterns that suggest vast standing bodies of water once existed on Mars. WaterWave, a recent study, found hydrothermal activity in Mars' crust, which could have kept the water warm enough to remain liquid for millions of years. But if Mars had an ocean, where did all that water go? And what caused the planet to lose its ability to sustain liquid water? Keycap 2: Ancient river valleys and deltas, the evidence of flowing water. One of the most striking features of Mars geography is its vast network of dried-up river valleys. The Valles Marineris Canyon system, one of the largest in the solar system, is thought to have been shaped by massive floods. The Curiosity rover explored Gale Crater, where it found smooth, rounded pebbles, a sign that a river once flowed through the area for thousands of years. The Perseverance rover landed in Jezero Crater, which once held a lake and a river delta, making it one of the most promising places to search for signs of ancient life. Small Blue Diamond, the largest river system on Mars. Satellite NASA's Mars Reconnaissance Orbiter detected huge branching river channels similar to those found on Earth. Globe showing Europe-Africa, these channels indicate that rain or melting ice once fed long-lasting river systems. These dried-up riverbeds tell us that liquid water was once abundant, but something changed Mars' climate forever. Keycap 3: The Volcanoes of Mars, a planet on fire. Mars is home to the largest volcano in the solar system, Olympus Mons, a colossal volcano nearly 3 times the height of Mount Everest. Small Blue Diamond: How Mars volcanoes shaped its climate. Mars volcanic activity was once widespread, producing lava plains, mountains, and ash deposits. Volcanoes released massive amounts of carbon dioxide and water vapor, which could have contributed to a thicker atmosphere and warmer temperatures in the past. The Tharsis volcanic region, home to Olympus Mons, Arcia Mons, Pavones Mons, and Ascreus Mons, may have helped create a temporary greenhouse effect, allowing liquid water to exist on Mars. But as volcanic activity slowed, Mars' climate began to change, setting the stage for the planet's dramatic transformation. Keycap for the disappearance of Mars' atmosphere, the beginning of the end. Mars once had a thick atmosphere, allowing liquid water to exist. But something caused it to disappear. Unlike Earth, Mars lost its protective magnetic field around 4 billion years ago, allowing solar wind to strip away its atmosphere. The MAVEN mission confirmed that Mars continues to lose atmospheric particles to space, meaning the planet is still changing today. With a thinning atmosphere, temperatures dropped, water froze or evaporated, and Mars became the dry, cold desert we see today. Small Blue Diamond: Could Mars' atmosphere be restored? Satellites, some scientists believe terraforming could restore Mars' atmosphere, but it would require vast resources and technology beyond our current capabilities. Globe showing Europe-Africa, Elon Musk and NASA have proposed ideas for releasing stored carbon dioxide or using large-scale greenhouses to slowly rebuild an atmosphere. Could we one day reverse the process and bring Mars back to life? Keycap 5: The Mystery of Ancient Martian Life. If Mars had water, volcanoes, and an atmosphere, then could life have existed there? scientists have discovered organic molecules in Martian soil, suggesting that the building blocks of life were present. Some researchers believe microbial life could have thrived in Mars' ancient lakes and hydrothermal vents. Future missions, like NASA's Sample Return mission and the European Space Agency's ExoMars, aim to search for direct evidence of past or present life on Mars. If we find life on Mars, it would change everything we know about our place in the universe. Summary of the geography of ancient Mars. Heavy checkmark: Mars once had vast oceans, flowing rivers, and a thick atmosphere. Heavy checkmark: its largest volcanoes may have helped create a greenhouse effect, making the planet temporarily warm. Heavy checkmark: something caused Mars to lose its atmosphere, likely solar wind after the magnetic field disappeared. Heavy checkmark: signs of ancient rivers, deltas, and lakes suggest Mars may have supported microbial life. Heavy checkmark: future missions will search for direct evidence of past life on Mars. Mars today is a cold, barren wasteland, a world of dust storms, radiation, and extreme temperatures. But if we look closely, we can still find traces of its ancient past. Even after billions of years, the fingerprints of a wetter, more Earth-like Mars remain etched into its surface. Keycap 1. The frozen remains of Mars water. Even though Mars lost most of its liquid water, evidence suggests that some still remains, locked in ice and hidden underground. Small blue diamond: the Mars Odyssey spacecraft detected vast amounts of frozen water beneath the Martian surface, particularly near the polar ice caps. Small blue diamond: the Mars Express orbiter found what appears to be a subglacial lake beneath Mars' south pole, similar to subglacial lakes on Earth, like Lake Vostok in Antarctica. Small blue diamond: the Phoenix lander in 2008 even touched and confirmed the presence of water ice, which evaporated when exposed to the Martian atmosphere. Could this frozen water be the key to future human colonization? Keycap 2. The atmosphere of Mars, a thin and hostile remnant. Mars still has an atmosphere, but it is incredibly thin, just 1% the density of Earth's. Small orange diamond: composed mainly of carbon dioxide, CO2, the atmosphere provides little protection from radiation and is too thin to support liquid water. Small orange diamond: the MAVEN mission confirmed that solar wind is still stripping away Mars' atmosphere today, making it unlikely that the planet will naturally regain a thick atmosphere. Small orange diamond scientists believe that ancient volcanic eruptions once replenished the atmosphere, but without active volcanoes, Mars can no longer hold on to its air. For humans to live on Mars, we would need to find ways to rebuild its lost atmosphere. But is that even possible? Keycap 3. Mars today, a world of extreme conditions. Despite its Earth-like past, modern Mars is one of the harshest places in the solar system. Thermometer temperature extremes. The average temperature on Mars is minus 63 degrees Celsius, minus 81 degrees Fahrenheit, but it can drop as low as minus 125 degrees Celsius, minus 195 degrees Fahrenheit at night. Occasionally, daytime temperatures at the equator can rise above freezing, but it's still too cold for liquid water to exist. Tornado: massive dust storms. Mars experiences planet-wide dust storms that can last for months, blocking sunlight and covering the entire planet in a reddish haze. These storms can be so intense that they once disabled the Opportunity rover permanently in 2018. Red circle radiation exposure. Without a magnetic field, Mars is bombarded by cosmic radiation, making it hazardous for both robots and future human explorers. Astronauts on Mars would need underground shelters or radiation-proof habitats to survive long-term. For humans to live on Mars, we must overcome these extreme conditions. But could Mars be terraformed into a habitable world? Keycap 4. Could Mars be brought back to life? Terraforming the red planet. The idea of terraforming Mars, transforming it back into a warm, Earth-like world, is one of the most exciting challenges in planetary science. Small blue diamond: potential methods for terraforming Mars. Satellite releasing CO2 from the polar ice caps. Mars still has some carbon dioxide trapped in its ice caps. If released, This could create a greenhouse effect, warming the planet and thickening the atmosphere. Collision artificial magnetic field. Scientists have proposed placing a large magnetic shield in space to protect Mars from solar wind. This could allow the atmosphere to rebuild naturally over time. Sun large-scale greenhouses and microbial life. Some researchers suggest using heat-producing bacteria or algae to slowly generate oxygen on Mars. This would take thousands of years, but could create a more Earth-like environment. But could humanity really reshape an entire planet? Or is Mars destined to remain a barren wasteland forever? Summary of modern Mars and its challenges. Heavy check mark, Mars still has water, but mostly in the form of ice and underground reservoirs. Heavy check mark, its atmosphere is too thin and continues to be stripped away by solar wind. Heavy check mark, modern Mars is a world of extreme cold, massive dust storms, and high radiation. Heavy check mark, terraforming could make Mars habitable, but would require enormous technological advancements. For centuries, Mars has fascinated humankind. Once thought to be a dying world, we now know it was once a planet of water, atmosphere, and possibly even life. Today, we stand on the edge of a new era, one where Mars could become our second home. But how do we get there? And what challenges must we overcome? Keycap 1. The next missions to Mars, preparing for human exploration. Before humans can set foot on Mars, robotic missions are paving the way. Rocket NASA's Artemis program and Moon to Mars strategy. NASA's Artemis program is focused on establishing a lunar base, which will serve as a stepping stone for missions to Mars. The Lunar Gateway Station will allow astronauts to practice deep space travel and test critical technologies. Satellite, the Mars Sample Return Mission 2030s. NASA and the European Space Agency, ESA, are working on a mission to bring Martian rock samples back to Earth. These samples will help scientists determine if Mars once had microbial life. Rocket China's Mars plans. China successfully landed its Zhurong rover in 2021 and has ambitions for a human Mars mission by the 2030s or 2040s. But the real challenge is not just reaching Mars, it's surviving once we get there. Keycap 2. The challenges of colonizing Mars. Living on Mars won't be easy. Astronauts will face extreme conditions, limited resources, and the need for constant innovation. Small blue diamond, the key challenges for human settlement. Thermometer, extreme cold. With average temperatures of -63 degrees Celsius, -81 degrees Fahrenheit, habitats will need advanced insulation and heating systems. Tornado, radiation exposure. Mars lacks a protective magnetic field, exposing astronauts to dangerous cosmic radiation. Possible solutions include underground bases or radiation-blocking materials like water shields. Fork and knife with plate, food and water supply. Transporting food from Earth is not sustainable, so scientists are working on Martian greenhouses to grow crops. Water extraction from underground ice will be crucial for survival. If we solve these challenges, we won't just visit Mars, we'll stay there. Keycap 3. SpaceX and the vision for a Martian colony. Elon Musk's SpaceX has the most ambitious goal: to build a self-sustaining city on Mars. Rocket Starship, the rocket that will take us to Mars. SpaceX's Starship is designed to be fully reusable, making interplanetary travel more affordable. It could transport 100+ people per trip, along with cargo for building settlements. Cityscape, building the first Mars colony. The first Mars settlers would likely live in habitats buried under regolith, Martian soil, to shield against radiation. Over time, the colony could expand with robot-built structures, 3D printed buildings, and advanced life support systems. Could this be the first step toward making humanity a multi-planetary species? Keycap 4. The long-term vision, a new home for humanity. Small blue diamond, what will a future Mars colony look like? How self-sustaining cities. Future cities on Mars may include massive biodomes, underground tunnels, and even floating habitats in the thin atmosphere. High-voltage nuclear and solar power. Mars has abundant sunlight for solar panels, but nuclear reactors may provide more consistent energy for long-term settlement. globe showing Europe, Africa, terraforming, turning Mars green again. The ultimate goal could be terraforming Mars, thickening its atmosphere and melting its ice caps to bring back liquid water. This process could take centuries or even millennia, but if successful, Mars could one day support forests, lakes, and even a breathable atmosphere. Could this be the destiny of the Red Planet? Summary of the future of Mars exploration. Heavy checkmark NASA, China, and private companies like SpaceX are actively working on sending humans to Mars. Heavy checkmark surviving on Mars will require solving major challenges, including radiation, food production, and extreme cold. Heavy checkmark SpaceX's Starship could revolutionize Mars travel, making colonization possible. Heavy checkmark long-term, humanity may terraform Mars, turning it into a second Earth. Final thought, a message to the future. For thousands of years, humans have looked up at Mars and wondered, could we ever set foot there? Could we build a new home beyond Earth? Today, those dreams are closer than ever to becoming reality. The journey to Mars will not be easy, but it will be one of the greatest adventures in human history. One day, someone will be the first person to walk on Mars. Maybe they're alive today. Maybe they're watching this video. And maybe, just maybe, that person is you.